In recent years, there has been demonstrable potential using electroencephalographic signals and feedback for the development of brain-computer interfaces for limb rehabilitation. This presentation is a review of the state-of-the-art, opportunities, and limitations in the development of BCIs to support the rehabilitation of upper and lower limbs of the human body. To this end, a systematic review was conducted in the databases PubMed, IEEE Explore, Scopus, and Web of Science, the results of which show studies published between the years of 2003 and 2020. Of the total number of records found with the search parameters, and according to the flowchart of the review, 18 studies ultimately met all of the inclusion criteria. For studies to be included in the review, the following aspects were taken into consideration: the use of EEG signals as part of signal acquisition, studies whose focus is to propose a brain-computer interface to rehabilitate upper and/or lower limbs through motor intention or assistance with movement, and the employment of virtual environments as part of feedback. Also, studies were excluded that did not specify signal processing within the interface, studies that did not indicate the control system employed, studies that were analysis of the design processing, or if the articles were reviews. Of the 18 included studies, which were published between the years of 2011 and 2020, it was identified that 61.11% of the proposals correspond to applications whose objective was to rehabilitate the upper limbs, 33.33% the lower limbs, and 5.56% both kinds of limbs. In addition, 44.44% of the studies focused on applications dealing with virtual limb simulation, 27.78% on the use of games, 11.11% on the development of wheelchairs, 5.56% on orthosis, 5.56% on functional electrical stimulation, and 5.56% on the use of skeletons. On the other hand, 33.33% of the studies combined visual and auditory feedback, 11.11% used haptic and visual feedback, and 11.11% had visual, auditory, and haptic feedback. In addition, 27.78% made use of fully immersive virtual reality, 16.67% had semi-immersive virtual reality, and 55.56% used non-immersive virtual reality. In summary, the study showed that feedback within a BCI system increases the efficiency of the system, and that there is a need to further develop interfaces that are efficient, accessible to users, and that integrate visual, auditory, and/or haptic feedback techniques.